But the order of events is different too. And so that's something that I want to emphasize, because some people think that if you made the days long periods, millions of years, for example, Hugh Ross does that and he teaches that. But that doesn't work because the order of events is different. According to scripture, the earth's made on day one. In the beginning, God created heaven and the earth. Verse 2, the earth was without form and void. It's already there. Earth's already there on day one. God makes it first. And then he makes the stars on day 4. And that includes the sun and the moon. All the celestial objects are made on day 4. And so those galaxies, those are made on day 4 because galaxies are made up of stars and stars are made on day 4. Yes. And yet the Big Bang reverses that. The Big Bang says that stars started to form 300 million years after the Big Bang. They're going to have to revise that, by the way, because of the James Webb Telescope data, which refutes that. But nonetheless, they'll push it back to an earlier time. But nonetheless, stars form first, and then the Earth doesn't form until about 10 billion, well, almost 10 billion years later. So there's a huge difference of events: stars before Earth or Earth before stars. Big Bang says one, Bible says the other. So there you go. And the naturalistic time scale too includes things like fish evolved before fruit trees, for example. In the secular view, fish evolved first and then fruit trees are later. But according to scripture, fruit trees are made on day 3, fish are made on day 5. So the order does not match.
Hello, this is Brian Bowen from Apologetics 101. Here today with another video. This one is going to be an interview with Dr. Jason Lisle of Biblical Science Institute, and he's going to be discussing with me the origin of the universe, the so-called Big Bang Theory, the problems associated with that, the age of the universe, that sort of thing. But it's going to be primarily centered around the origin of the universe, and that includes the origin of the solar system and so forth. And we have a really interesting conversation. We had a few technical difficulties with my Zoom, but I was able to smooth all that out in editing, so it looks like one good video. And I do realize, though, that because of all the distractions, some reason I got distracted a lot. I didn't give Dr. Jason Lisle a proper introduction, so I'm going to give him a proper introduction at this point. And I do apologize if he's watching this. I'm sorry that I didn't give you a proper introduction. I had so much distraction that I just kind of spaced it out, I guess. But since I'm doing this opening for the interview, I want to go ahead at this time and basically give an introduction to who Dr. Jason Lisle is. I understand that most people know who he is. So he's a man who doesn't need an introduction, but he certainly deserves one. He's done so much for the church, and I really appreciate him coming on here and having a discussion with me on the topic matter of the origin of the universe. Now, on my other computer, I'm actually on the Biblical Science Institute, which, by the way, I will be linking his website for his online ministry there, biblicalscienceinstitute.com, and I will be linking that in the description box below. They have he has a lot of great articles on there. It is an awesome site to go through. He's got a lot of good videos, so I would recommend go check that out if you haven't already. And okay, with Dr. Jason Lisle, according to his bio on his site, it says Dr. Jason Lisle is a Christian astrophysicist who researches issues pertaining to science and the Christian faith. A popular speaker and author, Dr. Lisle presents a rational defense of a literal Genesis, showing how science confirms the history recorded in the Bible. Brought up in a Christian family at a young age, he received Christ as Lord. Since then, Lisle has always desired to serve the Lord out of love and gratitude for salvation, and to spread the gospel message to all people. Dr. Lisle double majored in physics and astronomy with a minor in mathematics at Ohio Wesleyan University. He then went on to obtain a master's degree and PhD in astrophysics at the University of Colorado in Boulder. There he used the SOHO spacecraft, which he does mention the Soho spacecraft later when he talks about comets. I think he mentions that. Um, there he used the Soho spacecraft to analyze the surface of the sun and made a number of interesting discoveries, including the detection of giant cell boundaries. Since then, Lisle has worked in full-time apologetics ministry. He wrote a number of planetarian shows for the Creation Museum, including the popular Created Cosmos. Dr. Lisle has authored a number of best-selling books on the topic of creation, including Taking Back Astronomy, Stargazer's Guide to the Night Sky, The Ultimate Proof of Creation, Discerning Truth, and Understanding Genesis. I actually have almost all of those books except for Stargazer's Guide to the Night Sky. The rest of them I actually have. And then some. He's written a lot of books on this particular topic and other topics, and so I've got a lot of his books. I don't got all of them, but I've got a lot of them. And he's a pretty nice guy. He's an astrophysicist, and that's one of the reasons I invited him on this to have this discussion on the origin of the universe, because this is his area of expertise. So he's very familiar with both the Christian and the secular research and models and things like that people have come up with, and so he understands them very well, and it was a great opportunity to have a conversation with Dr. Jason Lisle. I'm glad he was able to join me on my channel, in spite the technical difficulties that we have. Like I said, the Zoom just kept cutting off on us, but I was able to smooth all that out in editing, so it looks like one video, so you don't have to worry about all the interruptions that we had to go through and so forth. But in any given case, without further ado, let's cue the interview and go from there. It is great to have you here again. I want to try to switch this to side by side view.
I think if you just pull on a corner of the window and rescale it so it's wider than it is tall, it'll do that automatically.
It's got a speaker gallery immersive full screen. Oh, awesome. All right. So how you been doing, Dr. Jason Lisle?
Wow, pretty good. How about you?
Awesome. It's been a while.
Yeah.
I'm doing a very big Genesis series on my YouTube channel, and
Good.
I am doing one today on the origin of the universe, and so we're going to be getting into subjects like the Big Bang Theory and that sort of thing, that the secular model, and of course the biblical understanding of the origin of the universe and that sort of thing.
Okay.
First, I think we probably need to start with a understanding, because I mean, as Christians, we want to be able to honestly deal with the other person's position properly, and because we want our position to be fairly treated and not someone straw man us or something. So kind of give a stillman understanding of what exactly is the Big Bang Theory, and the reasons that secularists would take this position.
Okay. The Big Bang Theory, it was invented in 1931 by Lemaitre, a guy named George Lemaitre, and he was trying to explain the observation that galaxies in the universe most of them are moving away from us, and the farther away a galaxy is, the more it's moving away, the faster it's moving away, as if the entire universe is expanding. And Lemaitre thought, well, if we run it backwards, maybe the universe was smaller in the past. If you run it back, eventually you get back to a point, and maybe that's where that's the time where the universe began. And he was trying to explain the origin of the universe and the expansion of these galaxies, the redshifts of these galaxies, in a naturalistic way. That is, he was trying not to appeal to the biblical God. Now, he did believe in God, but he didn't think that when you do science, he was what we would call a methodological naturalist. He believed that when you did science, you should leave God out of it. And I reject that philosophy, but that was what he embraced. And so it became then, the Big Bang became the standard explanation that atheists use to explain the origin of the universe. And then a lot of folks that are not atheists kind of jumped on it because they said, well, maybe that's the way God did it. And so basically the story is that the universe starts at a point of no size. That's called a singularity. And all the energy in the universe is in that point. All the mass, everything that would eventually become galaxies and stars is all compressed into a point smaller than an atom. In fact, it has no size at all. And that's called a singularity. And then the idea is, and by the way, even space is in the singularity. And that's something that's really kind of wild. And a lot of people don't get that. And again, I'm not embracing this model, but I'm trying to accurately represent it. Normally we think of a point as being surrounded by empty space. The singularity of the Big Bang was not even surrounded by empty space because space is in the point. That's kind of weird, but that's the model. And then this point rapidly expands for whatever reason, and it carries energy. So the energy begins to spread out. And as it does that, it cools. That's just from students who've had the ideal gas law, PV equals nRT. You have a larger volume, the temperature is going to go down from essentially infinity down to more reasonable values. Now, at this point, you don't have atoms yet. All you have is just extremely high energy particles. Atoms can't form yet because it's too hot. And so you just got very hot, high energy. And then once it reaches a certain size, and it takes about 300,000 years for the energy to have cooled enough that electrons can start dropping into around protons and neutrons and form atoms. But the only atoms that form in the Big Bang are hydrogen and helium and just trace amounts of lithium. Those are the three lightest elements, three on the top of the periodic table. That's the only elements that are supposed to be made by the Big Bang, those first three. And so then at about 300 million years after this Big Bang, the temperature has cooled enough that this gas, primarily hydrogen gas, a little bit of helium, a little bit of lithium, some of it gravitationally attracts and forms into stars. And so the first stars are supposed to appear 300 million years after the Big Bang. And then those stars collect into galaxies. And then those stars then, as they lose fuel in their core, some of them explode in a supernova. Now, we've seen supernova in nearby galaxies. We know that does occasionally happen for whatever reason. And the idea is that when stars supernova, there's sufficient energy to fuse hydrogen, helium, lithium into the heavier elements. And so that's where you get stuff like oxygen, nitrogen, carbon, the stuff that we're made of, the heavy stuff, is supposed to be produced in these first stars, which themselves are made of only hydrogen, helium, and lithium. But then when they explode, they pollute the universe with these heavier elements. And so the next generation of stars that forms, they have some of the heavier elements in them too. They have a little bit of oxygen, a little bit of carbon, a little bit of iron, things like that. And so that would be the next generation of stars then. And then basically that is supposed to explain why we have the 90 or so naturally occurring elements that we have in the universe. They weren't produced in the Big Bang. Only the first three are produced in the Big Bang. And then stars are supposed to produce the rest of them. And since the Earth has a lot of these heavier elements, secularists believe that all the material that makes up the Earth, except for the hydrogen and water, and a little bit of helium, was produced in the core of stars. And so secularists like to say we're all made of stardust. And so if you've heard that expression, that's why they hold to that. And then, of course, on one planet, Earth, life evolves from chemicals and so on. So that basically is the secular story of how the universe began and how it came to be the way that it is today. And there is a certain logic to it, but there's some problems with it as well, which I presume you'll want to talk about. But that's basically the story.
Right. Now, with the singularity, actually, I was going to bring this up, but I didn't want to interrupt. But from what, actually, I heard that you, there's a book right here called Dismantling the Big Bang by Alex Williams and John Harnett. I think I read online that you acted as a consultant for this book.
Yep, I was one of the reviewers on it. Yep.
Awesome. But in this book, they described the singularity that's claimed by the Big Bang is essentially what they call a naked singularity, because a singularity like in a black hole has still has space around it. It still has matter, around it, and an event horizon, that sort of thing. But the singularity to the Big Bang doesn't have anything around it. I mean, it's not even got
Right.
space.
Right.
So it's called what they call a naked singularity. And
Yep.
so, is there any evidence for singularities? Do they know that they do exist?
Well, not directly, but I would say that the physics of black holes is pretty well understood, and we think that at the center of a black hole there would have to be a singularity, but as you pointed out, it would not be a naked singularity because it would be surrounded by space, and then at a certain point there's what we call an event horizon. The event horizon of a black hole is the point of no return. That's what we think of as the hole. Okay, so once you get inside the event horizon, you have no choice but to be pulled gravitationally into that singularity and crushed, and then it increases the mass of the singularity, though not its size, because it has no size. So I think and I think there's very compelling evidence of black holes. There's no doubt that black holes exist, and all the physics we understand tells us that in the middle of a black hole, there would have to be a singularity, but it's not a naked singularity. And as far as we know, there is no evidence for a naked singularity, one that is not surrounded by an event horizon. So the kind, and I think that's important, because the kind of singularity that the Big Bang requires is not the kind that we think probably does have some good supporting evidence, namely the singularity of a black hole.
Why do secularists think, what did they think about why this singularity is just hanging there? Exactly, I don't know if that's even the proper terminology for it, but exactly where do they think it comes from, or they just don't have an idea?
Yeah, well, there's disagreement on that, because there's not a really good answer for it coming from the secular camp. There are those who would say, well, they would just say, we honestly don't know why the singularity got there or why it started expanding suddenly. Others would say, well, there's a God behind this. God created the singularity. Okay, that's not a real popular position, but there are some who hold that. And then one of the more popular views these days is that the singularity comes from another universe. So the idea is there's another universe out there, and it's producing these singularities that balloon into other universes. And so we're all part of this cosmic multiverse. And that's a very, that idea is catching on a little bit. I don't think it's very scientific, because you can't possibly detect another universe, because
I was actually going to ask you about that, because I was going to say that parallel universes is actually beyond the scope of regular science, because science can deal with the here now and the universe as we observe it. But a parallel universe, by definition, would be beyond the scope of what we can actually detect.
Yeah, it makes for good Marvel movies, but that's about it.
Right. But anyway, let's talk about the biblical problems wrong with the Big Bang first, because me and you are both presuppositionalists, so we do believe in starting with the Bible, and the Bible should take priority over anything else that we discuss. So let's start off. Well, for one thing, the first thing is that the Genesis 1:1, it does show that God created from absolute nothingness. Now, interesting enough, when secularists use the word nothing, they may not mean nothing in the same sense that Christians mean it. Christians, when we mean nothing, we mean not anything at all, not space, not time, not matter. We don't think that there was a universe before God created the universe, creating from pre-existing matter or something. We like Aristotle said, nothing is what rocks dream about. It's absolute nothingness. But when secularists use the word nothing, they mean it almost kind of loosely, because they'll call things like quantum fluctuations nothing. Like there's something that when I did my existence of God video, it was like there's these particles called virtual particles that they claim that come from nothing, but they come from quantum fluctuations. And and I know you did a series of articles on particles. I don't know if you covered virtual particles or not.
I did, yeah.
But am I right that comes from quantum fluctuations, but they'll call those quantum fluctations nothing. And they'll say, that's an example of something coming from nothing.
Yeah, sometimes you'll hear physicists say that. I don't think they're trying to be deceptive or anything. They're just being a little less than precise. They'll say, particles can pop into existence from nothing. Well, they're not really popping into existence from nothing. They're popping into existence as a disturbance of a field in the vacuum of space, which is not nothing, it's something. And so nothing comes from nothing. That's logically impossible. So you can't have effects without causes. But but it is true that these little virtual particles can pop into existence they're borrowing a little energy from space, and then they have to pay it back within a certain time that's determined by the Planck constant. But yeah, so it's not truly not. Space is not nothing. Space is something, and it's very busy. It's got these virtual particles in it. It's three-dimensional. The fact that space has 3 dimensions and not 7 and not 16 and not 2 tells you it's something, right? It's not nothing, because nothing can't have properties. So
Right. Um, uh, Also, another thing, something else I've been studying on Genesis 1:1 is that in the beginning, God created the heavens and the earth. Some people have come up with, like theistic evolutionists, come up with this type of uh, argument called the dependent clause translation, where they would try to translate Genesis 1:1 as the dependent clause in order to not make it the first act of creation and deny creatio ex nihilo. And well, what do you think of that?
yeah, I mean, it doesn't stand up to scrutiny, and folks like Dr. Stephen Boyd, whose PhD is in Hebrew, have written on these topics, and they're more knowledgeable of it than I am. But nonetheless, the phrase there, Bereshit bara Elohim, in the beginning God created, it really means that. If you wanted to say it was in the beginning of God's creating, or in the
when that God created.
Yeah. There are other words you would use for that. Everywhere else, Bereshit is used. Bereshit, in the beginning. It always means in the beginning. Everywhere else that you see in Scripture. And if you wanted to say God began creating or something like that, there are other words you would use to say that. So Bereshit really does mean in the beginning.
In my research, the theistic evolutionists would argue that because Bereshit lacks a definite article, then it should be translated as a dependent clause. But temple phrases often had lack definite articles. Like a good example of that would be Isaiah 46:10. That's when God's saying he knew the end from the beginning. And the word from the beginning, Mereshith, is actually in the same form as Bereshith. It's got a preposition and it's got the Reshith, word Reshith, but it's like a definite article, and yet it's in the absolute state in Hebrew.
Yeah, you got to be real careful about that, because in Hebrew, so just to back up, just in case, just for the audience to understand these things, when we talk about the definite article, we're talking about like the God, as opposed to just a God, for example. And there is no indefinite article in Hebrew. There is no a God or a beginning. But you got to be careful, though, because some things that in English we would use the definite article for it, the beginning. In Hebrew, they don't. The definite article in Hebrew is ha. So you'd think it would be ha reshith, the beginning, but it's not. It's just reshith, and to prefix it, to say in the beginning, it would be bareshith. You'd add ba right to the word. It's attached to the word. But I can't find anywhere in Scripture where it's Bahareshith. I can't find that. It's never used that way. So in all the places where it's in the beginning, like in the beginning of such a king's reign, in the beginning of his reign, it's Bereshith. So that's the translation of that. Bereshith means in the beginning. It's not in a beginning of a king's reign. A king has one beginning to his reign. It's that beginning. It's just that in Hebrew, some things that in English we would put the definite article on it. In Hebrew, you don't, but it nonetheless has that meaning. So there's no doubt that Bereshith means in the beginning. And of course, and it's always been understood that way until modern times, when people have tried to incorporate the secularist view and try to make the Bible compatible with that, but it doesn't work.
It's usually theistic evolutionists that hold this position. I mean, it's not just any old earth creationists. It's people that literally trying to make Genesis compatible with evolution, and including the deep time assumptions and that sort of thing.
Yeah.
But I am going to do a big for everybody else to know. I am doing a big presentation on the traditional translation versus the dependent clause translation. Hebrew is something I do study. But it's something that they propagate a lot on as far as Genesis 1:1. Now, of course, the Genesis 1:1 also difference, or Genesis 1 also difference is in the time scale and the order of events from the Big Bang Theory.
Yeah.
Did you want to discuss some stuff on that?
Sure. Yeah. So the order of events. Well, let's just start with the time scale. The time scale of the Big Bang. I already mentioned that it's supposed to be 300,000 years before atoms can form, and then it's another 300 million years before stars form, and then it's another about 10 billion years before the Earth forms. And of course, scripturally, we know that God created in 6 days, and people try to argue that too. But if you're knowledgeable of Hebrew, that it's using the normal word for day, yom, which in the context of Genesis always means an ordinary day because it's defined as an Earth rotation. An evening and a morning defines a day, and that's right there in Genesis 1:5. So where vahi erev vahi boker yom echad. So it's in there was evening, there was morning, day one day. And then the other days follow and so on. And then the 6th day and 7th day they do have the definite article. So it's the 6th day, it's the 7th day. There's no doubt about that. So God created everything in 6 days, not 13.8 billion years, which is the current belief. That's the age of the universe according to secularists currently. That number changes a little bit every few years as they reestimate things, but they believe it's billions of years old. And there's just no way you can cram that into scripture. And Christians have tried because we get intimidated and we think the secularists have to be right about origins. And there have been all kinds of mechanisms. People try to put a gap in between verse 1 and verse 2, and that doesn't work in terms of the Hebrew, or it's just a beginning, but it's not the beginning. That just doesn't stand up to scrutiny. Or they'll try to make the days long, or whatever mechanism. It just doesn't work. But the order of events is different too. And that's something that I want to emphasize, because some people think that if you made the days long periods, millions of years, for example, Hugh Ross does that and he teaches that. But that doesn't work because the order of events is different. According to scripture, the earth's made on day 1. In the beginning, God created heaven and the earth. Verse 2, the earth was without form and void. It's already there. Earth's already there on day 1. God makes it first. And then he makes the stars on day 4. And that includes the sun and the moon. All the celestial objects are made on day 4. And so those galaxies, those are made on day 4 because galaxies are made up of stars, and stars are made on day 4. Yes. And yet the Big Bang reverses that. The Big Bang says that stars started to form 300 million years after the Big Bang. They're going to have to revise that, by the way, because of the James Webb Telescope data, which refutes that. But nonetheless, they'll push it back to an earlier time. But nonetheless, stars form first, and then the Earth doesn't form until about 10 billion, well, almost 10 billion years later. So there's a huge difference of events: stars before Earth or Earth before stars. Big Bang says one, Bible says the other. So there you go. And the naturalistic time scale too includes things like a fish evolved before fruit trees, for example. In the secular view, fish evolved first and then fruit trees are later. But according to scripture, fruit trees are made on day 3, fish are made on day 5. So the order does not match. Dinosaurs, the secularists think dinosaurs evolved before birds. Some of them evolved into birds, according to some evolutionists. But according to scripture,
I can't stop that.
yeah. Yeah, if you see the latest Jurassic World movie, you'll see feathered dinosaurs in it and so on. I don't think those existed. But in any case, according to scripture, birds are made on day 5, dinosaurs are made on day 6, because dinosaurs are land animals. All land animals are made on day 6. So that order is different. Something else to think about too. Remember, in the secular view, the first stars that form have no heavy elements, right? It's just hydrogen, helium, a little bit of lithium. Things like oxygen didn't exist. And then after that first generation of stars goes, then they make oxygen. But according to scripture, oxygen already existed on day 1 because water existed on day 1 in verse 2, right? Because the Holy Spirit was hovering over the surface of the waters. Water's 2 parts hydrogen, 1 part oxygen. So oxygen's on day 1. Stars aren't made until day 4. So the presence of heavy elements, according to scripture, heavy elements existed before stars. But according to the secular Big Bang view, stars existed before the heavy elements, and in fact made the heavy elements. So they'd have to be prior to them. So there's all kinds of differences in the order. And so people who try to stretch the days out and make them millions of years, it's not going to work because the order of events is different. And I think God was very intentional about that. He made things in that way so that it could not be compatible with the secular views that he knew people would eventually come up with.
Is there evidence outside of the Bible of the Earth always having oxygen? Like, I think I heard that the rocks were, you look in the rocks, you can tell oxidation, and that
Yep,
there's
yep. The earliest by the secular dating method, rocks that we find on Earth have they have oxides in them, and not like things like carbide. You'd have carbides instead of elements. That basically, the way the chemistry works is there's evidence that the very earliest rocks oxidized, and so there was oxygen already in the Earth's atmosphere with the oldest rocks that we find on Earth. You don't find things like carbide. With the Earth had a reducing atmosphere, then you'd expect to find the oldest rocks to have things like carbides in them instead of carbonates. So the fact that we find carbonates and not carbides, yeah, the Earth's atmosphere is always had oxygen in it.
Since we're on the order of events, there is something I was wanting to talk. I already know how you're going to answer this because I often answer this same way. But in the case of light, that's something gets brought up a lot. How could there be light before God? Before God created the sun on day 4.
Mm-hmm. Yeah, and it's easy to answer. Light doesn't require the sun. There's other things that can make light. I've got light in this room. I don't have the sun in this room. I don't even have the windows open. I've got a light over here. I got a light up there, and so God can make objects that produce light besides the sun, and He did that for the first 3 days. God created the light itself, or He made a temporary object that made the light. But in any case, there was light for the first 3 days, and you can have light without the sun, because again, we got light in here without the sun. It's not really a problem. It's kind of a strange objection, you can't have light without the sun. Well, we all have light without the sun. When you turn on the lights at night, you got light without the sun. So God used a temporary light source for those first 3 days, and then He replaced that temporary light with the sun on day 4. And we don't know why He did it, but it could be because a lot of ancient cultures worshiped the sun as the primary source of life. And so God was maybe discouraging that by placing the sun on day 4. So God's saying, I'm the primary source of life, not the sun.
One of the objections, though, on the light thing is that what they're trying to argue is that before the 4th day, they're trying to say it wasn't really, actual 24-hour periods of time prior to that, because it lacked the sun to make it a day. And if I understood your response to this, usually is that all you need to make a day is a rotating planet and a light source.
Yeah, the sun doesn't go around the Earth. The Earth rotates. And so as long as you have a light source, whether it's the sun or supernatural light provided by God, as long as you have a rotating planet, you're going to have 24-hour days. The sun doesn't set the length of the day, at least not very much. There's a 4-minute difference between a sidereal day and a solar day, but God knows about that too. You're going to have ordinary days as long as you have a rotating planet. And we had a rotating planet on day 1 because there was evening and morning on the first day. So the Earth was already rotating, and God just provided the temporary light source. So of course you're going to have ordinary days before the sun. It's not a problem.
All right. Awesome. All right. And I have your book here, actually, Taking Back Astronomy too. And you mentioned that on the order of events, and Genesis 1 puts the Earth on day 1, right? Mm-hmm. Correct. Creating on day 1, which is quite different from the secular model, which sees it as billions of years. The universe and stars are all created before the Earth was created, and so forth. Because the secular model sees the Earth is like 4.5 billion years old, and the universe is almost 14 billion years old, and that sort of thing.
Yep.
All right. Okay. Okay. We discussed the biblical problems with it and the Pentecost. All right. There's some scientific problems wrong with the Big Bang Theory too, isn't there?
Yeah, quite a bit.
You want to discuss those?
Sure. Yeah. And I think the first thing I have to point out is that the Big Bang isn't really very good science anyway, because if you think about all those different things that have happened, according to the Big Bang, the universe starting as a singularity, we've never observed that. A singularity expanding, we've never observed that. Now, energy turning into matter, we have observed that. We can do that in high energy particle collisions, but there's going to be a problem with that, and I'll come back to that. And then the idea of stars forming from gas, we've never observed that. Stars collecting into galaxies, we've never observed that. None of these things have been observed. And good science really is about observation and drawing logical conclusions from those observations. And so I would say the Big Bang is not on good scientific grounding. Just as a story about the past, it does not have any real scientific support. And then on top of that, there are problems with the Big Bang. And I think I'll start with the flatness problem, which is the problem of it's sort of a fine balancing problem, because in a chance universe, if the universe just forms for whatever reason and it's got so much energy in it for whatever reason, it's expanding. Gravity is trying to slow that expansion, right? Because as galaxies are moving farther apart, the gravity is attractive. It's wanting to slow that expansion, and it is slowing that expansion. Gravity would like to stop it and bring the galaxies back together. But it turns out that if you measure the sort of the rate of expansion and you measure the gravitational force, they're almost exactly balanced to where gravity is just strong enough to slow the expansion to where in an infinite time, it eventually stops. Of course, we don't get to an infinite time, but it's never quite able to reverse it. And so the expansion rate is exactly balanced, as far as we can tell, with the gravitational force that would want to counter that. And that's amazing.
So,
go ahead.
Things get deteriorated over time. So that would mean that if you took the universe back, assuming the 14 billion years, just assuming their position, then when you got back to the singularity, from what I understand, the number is almost at what they say 1, which basically means almost completely perfectly balanced. And so the object of it is that the universe would either not be able to expand out at all, or it wouldn't expand out very much before collapsing back into itself. Although I would probably lean toward the idea that it wouldn't expand at all at that point. Yeah, so that's one is like absolute perfect balance. I'm not exactly sure how they come up with those numbers, but I do know that even secular astronomers like Alan Guth, I've actually heard actually mention that. I mean, he's the one who invented the inflation theory. We're not going to talk about that at the moment, but we'll probably talk about that in a little bit. After we deal with a few other problems wrong with it. You want to discuss the horizon problem?
Yeah, this is an interesting one because it's a light travel time problem, and I find that amusing because secularists sometimes chide creationists for saying, well, if you believe in 6,000 years, how do you get the light from those distant galaxies to Earth in that time when it should take billions of years? And we have answers for that, actually. I think pretty good answers. But in any case, they have the same type of problem in their model. And it's not a starlight problem, but it is a light travel time problem. So the idea is when the universe is very small, because starts as a singularity according to the Big Bang, and then it expands out. When it's very, very small, you're going to have different temperatures in different places. You're going to have hot spots and cold spots. Relatively cool. The temperature is almost infinite, but there's places that are a little hotter, places that are a little cooler. And that results from what's called the Heisenberg uncertainty principle. I won't go into details on that, but it's part of the model. And then the universe balloons out rapidly. And today we notice when we look to the farthest regions of the universe, we see this faint glowing cosmic microwave background, which secularists believe reflects that temperature of the early universe that's been cooled over time due to expansion. And we don't really see much in the way of hot spots and cold spots. It's very, very uniform. And so, I mean, there are minor fluctuations, but they're much smaller than the secularists were expecting. Secularists were expecting, well, if you got hot spots and cold spots and they get moved apart, you'll see a hot spot there and a cold spot there. You don't. They're all essentially the same temperature to within a small limit.
They usually average it out. Oh, sorry. Yeah, they usually average it out about 2.75 K.
That's right. Yeah, around 2.7 degrees above absolute zero. So it's rather chilly. But the problem is they ought to have hot spots and cold spots. And so how do you even out the temperatures? The only way to do that, the only way to even out the hot spots and cold spots is for the hot spots to dump the energy to the cold spots. And the good news is that'll happen naturally. If you put an ice cube in your hot coffee, you will eventually end up with lukewarm coffee. The heat will go from the hotter coffee into the ice cube, melting it, and eventually, you just get lukewarm coffee. Heat naturally goes from hot to cold. That's the second law of thermodynamics. So, but here's the problem. Those hot spots and cold spots are now on opposite sides of the universe, right? And so how would you get energy from the hot spot to the cold spot? Now, granted, they started out much closer, but as the light's trying to get from A to B, the universe is expanding. And so it's like a salmon trying to swim upstream, but kind of losing. How do you get the light from here to here, especially considering the light has just now gotten to Earth? Because that's what we're seeing. It would have to be, it would, no matter, and it doesn't matter if you make the universe older, it just makes it doesn't solve the problem. You think, well, you make the universe older, it gives the light more time. No, because now we can see farther because we're seeing more distant regions of the universe. So no matter how old you make the universe, the light from those distant cosmic microwaves is just now getting here. How could it possibly get twice that distance to the other side of the universe? It doesn't work. That's called the horizon problem.
Right. Because the speed of light.
Basically, they have to. Yeah.
Can't be.
Yeah, they have to get light from one horizon to the other in less time than is possible mathematically. That's the horizon problem. And then their solution for it, you mentioned inflation earlier. So inflation is the idea that the universe, when it's very small after the Big Bang, and it's expanded just a little bit, it suddenly starts expanding at a much faster rate, just really balloons out. And then at some point it stops and goes back to the slower rate. And even the slower rate's very fast. But this phase where it's accelerating its expansion is called inflation. And the idea is you can go ahead and exchange the light when the universe is pretty small and then balloon it out. And so the idea is that's how the light got from there to there, is because the expansion rate has not been constant. And I get that. And it's an interesting idea. I think it's a Band-Aid that's not quite going to fix a gaping wound, but nonetheless, that's the idea. And then there are problems with inflation, like why does the universe suddenly just start expanding at an inflated rate? And there are ideas behind that, symmetry breaking and so on. And why does it stop? And how does it stop everywhere at the same time? How does it know to stop here at the same time it stops there when these are now far apart regions? So inflation has its own set of difficulties. But if you've heard of inflation, it's an attempt to solve the horizon problem and the flatness problem. It at least reduces the flatness problem, because if you inflate the universe like that, that will tend to even out the gravitational versus the expansion rates. So that's inflation.
There is a number of problems I've heard about the inflation theory. Of course, besides the fact that it's ad hoc, it's basically a speculation about what they think happened as a result of that in order to try to explain something that's not adding up to what they observed. But besides that one, there's also a few other problems I heard about, one of them is a point that I think that Alex Williams and John Hurnett made in their book that I really liked. But I'm going to talk about the one that's commonly known. It's called the graceful exit problem, trying to get this to slow down, because I mean they have no actual mechanism by which to trigger it, and they have no mechanism which to stop it. But from what I understand, they also need to stop it. They kind of got to gradually ease out of it. Is that correct?
Yeah. Well, yeah. The idea is you want to stop it everywhere, and you want to stop it everywhere at the same time. And that's the real trick, because if some places are naturally just a little bit warmer than other places, whatever mechanism's causing it to expand, how do you shut that off everywhere at the same time? How do you let's all synchronize our watches. Well, they don't have watches. How do you do that? So that is known as the graceful exit problem. And I think that's one of the bigger problems with inflation. With the, starting it, they can say, well, symmetry breaking, and that gets complicated. It has to do with the unification of forces. But in any case, I think it's an issue as to how you get it to stop everywhere at the same time. And I don't think that's ever really been solved, to be perfectly honest with you.
Within the secular model, is the universe still forming during the time of the inflation? I mean, is the universe actually still forming, or is it already formed?
All the mass is already there. All the mass energy is already there. Other than space, it's if you believe in a lambda, space, it's dark energy. Space itself can have a sort of energy to it, but I would say nothing. The Big Bang, by its definition, is supposed to be naturalistic. Let's put it this way: there's nothing supernatural happening after the initial bang. And those who are theistic Big Bangers think that, well, God created that, but then everything else, it happens on its own. So is it still forming? Not in the sense of new mass being added. The mass is simply cooling during that time. And it's not until much later, it's not until 300,000 years after the Big Bang that you have actual atoms with electrons circling the nuclei.
Alex Williams and John Harnett makes an excellent point in their book on dismantling the Big Bang. The inflation theory would actually expand the universe out so fast it wouldn't have time for light to travel from point A to point B. You know what I'm saying? Like it goes from a marble to like the size of our galaxy, like really, really fast, probably in like what, a few nanoseconds or something. So that would expand out way too fast to allow like a chance to convert energy back and forth as far as the horizon problem. Is that correct?
I'm not sure. I think the idea is that it's before the inflation phase takes place that the temperatures get evened out to some extent. So I'm not sure about that one. It's a possibility, but I'm going to go ahead and accept, for the sake of hypothesis, the secular claim that it will solve or reduce the horizon problem. I'm just pointing out that you're replacing it with a model that has just as many problems, and so there's not really a net gain. And there are astronomers who embrace the Big Bang, but who reject inflation. And so that tells you it's got some issues with it. The fact that some secularists reject it tells you that it's got some pretty serious problems.
Now, the most popular view of the Big Bang model, and the one which is also accepted by old Earth creationists, is what's called the hot Big Bang model, where the temperature is like really, really hot in the initial beginning, I guess, because the singularities got infinite temperature and expands out, and it's like extremely hot, and it cools down, and that's where they think the CMB comes from, and that sort of thing. But if the universe was ever that hot, that would create what's called monopoles. Is that correct?
Well, that's the theory. Yeah, that's the theory, is that monopoles ought to be created at extremely high temperatures, the temperatures that are associated with the Big Bang. And just again, so people understand, a monopole is a theoretical particle, they've never been found, that has one magnetic pole. Now, all particles that we know of, you can have particles that have one electric pole, like electrons are negatively charged. They have just a negative charge, right? And protons have just a positive charge. Theoretically, you could have particles that have a north magnetic charge and particles that have a south magnetic charge, but we've never discovered them. Every magnet we find in nature has a north pole and a south pole, every one. And so theoretically, you could produce these particles at extremely high temperatures, the high temperatures associated with the Big Bang, that would produce these magnetic monopoles. The theory, from what we understand about electromagnetic theory, it does allow for them. There are Maxwell's equations. There's one where you set it equal to 0, which basically means there's no monopoles, but you could easily put a monopole in there and it would work perfectly fine. So the fact that we don't find magnetic monopoles suggests either that we don't understand physics very well, which could be the case, but we've been pretty successful in predicting quarks and things like that. The top quark was predicted and then discovered. The Higgs particle was predicted and then discovered. Or it means the universe never had the high temperature associated with the Big Bang. And I take the latter position.
I don't think the universe was ever that hot, personally.
Yeah.
I think it's pretty much all been pretty much static the way it is today.
Well, yeah, and we know, and biblically we know that, because we know that the darkness was on the face of the deep when the earth was first created. And so if it were incredibly hot, you can't have darkness, because heat creates light. So originally the universe, and you can't have liquid water for that matter, if temperatures more than 100 degrees Celsius. So under current atmospheric conditions anyway. So the universe was never that hot biblically, and the lack of monopoles seems to be pretty good evidence that that's the case.
I want to talk about my favorite problem wrong with the Big Bang theory that I like, or one of my favorite problems wrong with the Big Bang. It's called the Baryon number problem. It basically asks the question, where is all the antimatter? And I guess I like this one because I actually understand it very well. I'm not very good at math, so I can't figure out how they come up with one on the flatness problem. But when it comes to the Baryon number problem, I understand that the plus and minuses must equal out when energy is converted to matter. But do you want to explain that a little bit?
Yeah, and I agree with you. I think it's my favorite problem with the Big Bang too, and it is one of the easiest to understand. It really is. So baryons are things like protons and neutrons. Okay, they're nucleons, particles made of quarks. And so, and we can make protons in a laboratory. We can take particles together, smash them together at extremely high energies, and from the energy, particles will form from that. We can do that in a laboratory. And some of the particles that form are protons. But every time we make a proton from that energy, an antiproton also forms. Now, an antiproton is just like a proton. It's got the same mass, same size, but it's negatively charged. And in fact, pretty much every particle in nature has an antiparticle that is identical, except the charge is reversed. And so technically you can have antineutrons too, and they're made up of, and you say, how do you, well, they're both neutral. Well, an antineutron would be made of antiquarks and so on. But anyway, bottom line is whenever energy turns into matter, it produces an equal amount of antimatter every time. There are no exceptions to this that have ever been detected. And we've done hundreds of thousands of particle collisions in particle accelerators. Every time you make matter from energy, you get antimatter. Now, the claim of the Big Bang is that all the matter in the universe was once energy, and as it cooled, some of it turned into matter. Okay, we can do that in a laboratory, but every time we do it, we get antimatter. And so if all the matter in the universe came from energy of the Big Bang, there should be an exactly equal amount of antimatter in the universe. They have to balance, because when energy forms matter, it forms antimatter. And in fact, that appears to be a law of nature. It's a Baryon conservation number. The Baryon number is kind of the number of protons and neutrons, and it's a conserved quantity. And so if you start the universe with 0 protons and neutrons, the Baryon number is 0. It has to stay 0 for all eternity, which means the number of protons and neutrons has to equal the number of antiprotons and antineutrons, because they have a negative Baryon number. They're antibaryons. So the fact that the universe is essentially matter only is just a serious problem with the Big Bang, and one that has not really been resolved. I'm aware of the attempts to solve it, but it hasn't really been solved.
That's what I was fixing to ask about. What was the secular responses to the fact that we haven't discovered an equal amount of antimatter? Because universe has got a lot of matter in it. So, and a very little only trace amounts of antimatter, from what I'm saying, has been discovered in nature. So what is their response to this?
Okay, the only one that there have been several, but they're all along the same lines. All of these different theories suppose that every now and then, when energy turns into matter, it only turns into matter and not antimatter. So one time in 10 billion.
One exception.
Right? Yeah, one exception out of every 10 billion times or whatever. And so they're basically claiming that Baryon number is only a quasi-conserved property that occasionally can be violated. Now, keep in mind, we have no evidence of this whatsoever. And one of the first theories that supposed that occasionally there's an exception. One of the consequences of that theory is that protons can decay. They can transform into non-baryons, and with an extremely long half-life. And they tested that theory by having a tank of water, which of course has a lot of protons in it. And they waited a number of years for one of those protons to decay, because granted, the half-life is extreme, but if you have enough protons, you can, eventually one or two every year will disintegrate. And they did not detect any disintegrations of protons. And so we now know that the proton is either stable or it has a half-life much longer than predicted by that particular theory. And so that they're now onto secondary theories that say, okay, but maybe protons can last a lot longer, but they can still decay and what have you. But my point is, the first theory that tried to get around the Baryon number problem proposed the decay of a proton that should have been detected in these experiments, and it wasn't. And so that particular version, that's been refuted.
Awesome. All right. Population 3-star problem. You hinted at this earlier. Essentially, all the fresh stars ultimately should have all the lighter elements. Now, you mentioned lithium. Is it my understanding that at least in the Big Bang Theory, sometimes they will say maybe lithium was created, or trace amounts of lithium. Is that an actual? I mean, is there disputes over whether lithium was allegedly created during the Big Bang, or?
I would say no. It's just a question of the proportion of lithium is so tiny compared to hydrogen and helium It's just when you're communicating to laymen, do you mention it? We all agree that a trace amount of lithium could be made during the conditions of the Big Bang if those conditions existed. And I would agree with that. I just don't think those conditions ever existed. So sometimes they'll just say hydrogen and helium because how precise do you want to be? It's just a question of how precise you want to be. Okay, but anything heavier than lithium, because there's an energy barrier. I think it's between lithium and beryllium that you really shouldn't get any beryllium. And beyond that, carbon, oxygen, Big Bang can't produce that. Zero hydrogen, zero carbon. And those initial stars would be called population 3 stars. And there's actually been 2 refutations of that now, because secularists were expecting that some of these population 3 stars are those that have 0 heavy elements. And the idea is some of those, especially the red dwarf ones, their lifetime is potentially greater than 13.8 billion years. And so some of them should still be around. And so secularists have been looking in our own galaxy and in nearby galaxies for population 3 stars, and they haven't found any. That's refutation number 1, because you'd expect a few of them would survive till today, even in our current galaxies. And then the other is, as you look deeper out into space, secularists saying, you're seeing the universe as it was billions of years ago, and therefore the deeper out into space you see, the more population 3 stars you should see, until eventually you get to a distance where it's only population 3 stars. And that was one of the things the James Webb Telescope was supposed to detect, were these population 3 stars that have 0 heavy elements. And I've read, I don't know how many technical papers now where astronomers have reported that in the farthest galaxies that we've seen in the James Webb data, they have heavy elements in them. They've detected oxygen in these distant galaxies where they didn't think there would be any. And the cool thing is, I predicted that's exactly what they'd find. Back in January, I made some predictions about what the James Webb Telescope would find based on what the Bible says, and then my understanding of the universe that's based on the Bible. But of course, I have to go beyond that a little bit to make some guesses about metallicity and so on that the Bible doesn't specifically mention. But I predicted they'd find heavy elements, and they did. And so the secular predictions were wrong. The creationist predictions were right. And so that's another refutation of this idea of population 3 stars. I don't believe they exist.
I don't either. Some people have come up with, well, we'll talk about that a little bit when we get to star formation, but on the population 3 stars, that they usually classify them as population 1, 2, and someone later came up with the classification population 3. Essentially being, like you said, stars with lighter elements, but all the stars have been found have had heavier elements in it. I think when they can determine, like when a supernova blows up, they can determine all the elements there are just coming out, right?
Yeah.
And it's always heavier elements. It's never a lighter element.
Well, yeah, I mean, there's lighter elements too, but there's always, all stars that we know of have some heavy elements in them, all of them. And that includes when they blow up, because we can analyze their spectrum when they blow up too. And their spectrum always has heavier elements in it, always, no exceptions. So the first 2 populations were discovered really empirically. Just we noticed that as we analyzed certain stars, some of them tended to have more heavy elements and some of them tended to have less heavy elements. And so population 1, population 2, the sun is population 1. It has more of these heavier elements. And then some astronomers thought, well, maybe the population 2 stars are the older generation. They were born when the universe had less heavy elements, because stars had not been creating them for very long. And so then the idea is population 2 or the older generation, population 1. That doesn't really work out, because you can find stars that even by secular standards are different ages that are either population 1 or population 2. And so now it's more about where in the universe they occur. For example, the bulge of our galaxy tends to have more of the population 2 stars. The disk of our galaxy tends to have more population 1 stars, like the sun. And so I think it's just a matter of God organizing his universe in a way that we can study and classify. But the idea of population 3 stars, though, that's theoretical, and we've never found those.
Dr. Jonathan Saparti, in his book Refuting Compromise, mentioned another objection that sometimes they have is that they're trying to argue maybe that at least by the time he published his book, that maybe that population 3 stars are no longer around, and that's why we don't observe them. But as you argue that we should still observe these population 3 stars, they would if they're made entirely of lighter elements, then that would mean that they would burn slower, right? That they would last much longer than normal star, like with heavier elements. Do you think? I mean, I'm not a physicist, so I don't know.
So for the lower mass stars, it shouldn't make a difference. So stars with the sun's mass and lower, because those stars are powered by what we call the proton-proton chain, and it doesn't make use of heavy elements. The heavier stars, it makes a difference. The heavier stars, whether or not you have elements in them, because heavier stars, the way they fuse their hydrogen is primarily by what's called the CNO cycle, that stands for carbon, nitrogen, oxygen. And basically, at a certain temperature, carbon, nitrogen, and oxygen essentially become catalysts. They make the reaction happen more efficiently and at lower temperatures. And so the expectation is, and I'm trying to remember this right, I think the expectation is that population 3 stars that are very massive, because they can only be powered by the proton-proton chain, I think they get puffy, I think they get really big. But for stars, the sun's mass and lower shouldn't make much of a difference. And the population 3 stars that are the longest lived would be much lower mass than the sun. They'd be red dwarfs. Red dwarfs theoretically can last 15 billion years or more, longer than the secular age of the universe.
What is this thing I've heard that some people are trying to like have a chicken and egg problem where they need stars to try to form stars, where like a bunch of stars near each other blow up, and I mean, exactly what is the thing with that? I mean,
there are some challenges that you have to overcome if you're going to make a star by natural means. Now, God can speak stars into existence. We can't. But the secular idea is that there's gas in our galaxy, neutral hydrogen gas, and it's spread out over a large region of space. It's a nebula. You can see these in your telescope, like the Orion Nebula. And the idea is that some of that gas eventually collapses in on itself and forms a brand new star. But there are some problems with that. And there's some things that would want to resist that. And one of them is gas pressure. Gas doesn't want to just, all go into the corner of your room. It wants to spread out because the molecules are knocking each other around. And so they want to spread out. PV equals nRT. There's a pressure there, and that pressure is outward. And normally in most space, the gravity wants to pull stuff together. That's true. But normally the gas pressure is far greater. Like in a nebula, it's far greater than the meager force of gravity, because gravity is inversely proportional to the square of the distance. So the farther things are away from each other, the weaker gravity is, where gas pressure works a little differently. So you have to deal with gas pressure. You have to somehow overcome that. And one way to try to overcome that is to make the gas as cold as possible. Colder gas, PV equals nRT, lower the temperature, the pressure decreases. So that's what you want. You want low gas pressure. So that's an issue. And the way that gas cools, one of the primary mechanisms is if there's dust in it, the dust will radiate some of that heat away. So you need dust. Dust is made of heavy elements. That's important. Okay. So that's one problem. And then the other problem is angular momentum. If a cloud has just a little bit of spinningness to it, when it condenses in, it'll really spin like a skater when she pulls her arms in and she really speeds up. That's due to conservation of angular momentum. And the faster you're spinning, the more it wants to spread out again. If you've ever been spinning in a chair and tried to pull weights in, it's hard, and you'll speed up when you do it. It's hard because they want to go out, right? Due to conservation of angular momentum. And so that's a problem as well. And then there's the problem of magnetic fields. These gas clouds have a little bit of magnetism to them. And what happens when you try to push two magnets together of like charge? They want to repel. And so magnetic field lines do that too. So there are 3 things in nature that resist star formation: gas pressure, angular momentum, magnetic fields. And so what's a secularist to do? Well, try to cool the gas down as much as you can. You need dust to do that, to do it well, because gas itself is more or less transparent. It doesn't radiate very well, but dust will do that. Dust is made of heavy elements, so you need heavy elements. And then to overcome the angular momentum, to overcome magnetic fields, you need some kind of external pressure. And so one of the mechanisms by which secularists believe stars form is nearby supernova. Another star explodes, and that shock wave compresses the gas a little bit, and hopefully enough to get it to where gravity will take over. Because at a certain point, once you get it to a certain size, gravity will take over. That's fine. But I remember
at that point, it's a chicken and egg problem, because now you have to need stars to create stars.
Yeah,
because stars had already existed.
Right. And it's worse, right? Because not only do you need the supernova to create the stars, so you have to blow up a star to get one, and probably more than one. I remember one time sitting down with Russ Humphreys, and we kind of worked out the math for the magnetic field pressure. How would you overcome the magnetic field? And we figured you'd need about 4 supernovae to go off nearby at about the same time to get a new star to form. So you got to blow up 4 stars to make a new one. So it's really, but of course, maybe you can get, maybe there's several stars that form out of that. So maybe it's enough.
Lose more stars than you create one. I wouldn't want these guys doing my checkbook.
Exactly. Yeah. And then the other issue I mentioned is, how do you cool the gas? Dust. What's dust made of? Heavy elements. Where do you get heavy elements from? Oh, in the Big Bang, those are supposed to be produced by the stars. So how do you get the first stars? You don't have any supernova available because there aren't any stars to make it. You don't have any dust available to cool the gas. And so that's an issue, is how do you cool the first generation of stars sufficiently to where gravity will take over. So that is an outstanding issue in the secular community.
All right, I want to talk about the singularity a little bit more. From what I understand, no known physics actually works inside of a singularity. That's correct? That's true.
That's true. And that's regardless of whether it's a black hole singularity or a naked singularity. Now with a black hole, we at least have enough physics to describe what happens kind of outside the singularity, around it. We got that. But we don't know exactly what's happening at the singularity. That's true. And that's because we have a field of physics that deals with really strong gravitational fields, and that field is called general relativity. Okay, and so Einstein discovered that. We also have a branch of physics that tells you what happens in really small spaces, and that's quantum physics. But general relativity and quantum physics, they're not quite compatible with each other. And so we do not have, at the moment, we do not have a theory that explains what happens when you have a huge amount of gravity and in a very small space. And that's exactly the conditions that the singularity requires. And so currently we do not have any physics that can explain what happens in that situation, which means secularists have to take it on blind faith that a naked singularity can even exist, that it can expand, that it can do what it does. They don't have science on their side there, because that science hasn't been discovered yet.
Again, like I said, I'm not very good at math, but my understanding is all the equations that people try to come up with prior to the Big Bang always seem to fall apart. You don't actually get the equations to work until after the expansion. Is that correct? Because that's because of the you have an intense gravitational field, and we can do an intense gravitational field on large scales. General relativity tells us how to do that. But we don't know exactly what happens when you have an intense gravitational field on quantum scales, because quantum mechanics does not include general relativity. It ignores it. It basically ignores gravity. Quantum mechanics ignores gravity, or treats it as a force, whereas general relativity tells us that gravity is a curvature of space-time, and there's currently no theory that describes them both. There are attempts. You've heard of string theory. That's one of the attempts to try and unify general relativity with quantum mechanics, and there are others as well, but that's one of the more popular ones. But they're untested, and we still don't know what would happen in that situation. So secularists have to take it on blind faith that a naked singularity is possible, and that it could possibly expand the way they are hoping that it does. So it's not. My point is, it's not science. Right. Some people try to come up with what they think happened prior to the Big Bang, which, of course, I don't know how I don't know what the temporal lingo would be because it's prior to time, and you can't have it
Mhm.
be. I mean, you just it winds up with all these self-contradictory statements. Uh, Alex Williams and John Hurnett mentioned something about when you compress all that matter into a singularity, it's considered a thermatic dead end. Could you be able to explain that, what that is exactly?
Yeah, I'd have to take a look at their book to be to be certain about that. But I think there might be some thermodynamic problems with crunching all that mass into a singularity. Um, there's a tendency in nature for energy to flow from a hotter source to a colder sink. That's called the second law of thermodynamics. There's some question as to whether or not the singularity in the Big Bang violates thermodynamics. It's not something that I've studied in detail, so I'm not ready to give a definitive answer, except to say there's a potential problem.
I believe they describe it like when you convert matter to that state, you've gone as far as you can go with it because you compressed it to a point to a point that's, I like to use my pen analogy, like smaller than the tip of my pen. It's compressed matter as far as it can go. And if you want to believe, and I think they said something to the effect of, if you want to believe that the universe came from that, it's fine. But you're claiming it came from a thermatic dead end, obviously, where all matter has been crushed into that point.
Mm-hmm. Although secularists would say, yeah, but space is also compressed in that point, and therefore we don't really know what happens. And it's true. We have no physics that can describe what happens in that scenario. So you can intuitively say, well, that's not possible, and maybe it isn't. But I guess my point would be, you can't definitively say that is even possible because we don't have the science to describe that kind of a situation. And it is a different type of singularity than the singularity in a black hole, where the singularity of a black hole is not going to disappear because that is a dead end for the matter. It's been crushed into that point. It's not going anywhere. The singularity of the Big Bang is theoretically different, and we don't have the physics to describe whether or not that's even possible at the moment.
The Nebular hypothesis, the origin of the solar system in the process. They believe that this happened as a result of a collapsing nebula, and they call it the Nebular hypothesis. But there's a number of problems wrong with that as well. Do you want to describe those?
Sure. Yeah. So the idea is that our sun forms the same way that they believe all the other stars form. A nebula collapses in on itself. We've already talked about some of the problems with that. The fact that gas pressure resists being compressed that way, magnetic fields resist it, and angular momentum is a problem as well. So but one advantage of that is it explains why all the planets are in the same plane. Because we Christians have often argued, well, that makes sense because God's a God of order, and so it makes sense that the planets are all roughly in the same plane. They're all within a few degrees of each other. Pluto is a little bit off, but it's not a planet anymore, so we don't have to worry about that. And some of the asteroids are off a bit, but the major massive bodies are all in the same plane, and it's roughly the same plane as the sun's rotation, but not quite. The sun's tilted about 7 degrees relative to the plane of the orbits of the planets, and that's an issue. Because how do you either have to tilt the orbits of all the planets the same amount by 7 degrees, or you have to tilt the sun by 7 degrees. And the sun is massive. How do you take something like that and just make it go 7 degrees? I mean, 7 degrees isn't a lot, but it's there. So that's a problem. And the fact that the sun's angular momentum is much less than that of the planets. You'd expect that if it all collapsed from the same cloud, the angular momentum ought to be comparable, in which case the sun ought to be spinning wildly. And so the theory is that the sun started out that way, but it's slowed over time due to magnetic braking and so on. But we've actually discovered some more problems with that model in that we've been analyzing other solar systems. And I actually have an article on this on the website on extrasolar planets. And I think it was a book. Okay. But I'm sure the existence of extrasolar planets is in the book, but on the article I brought in some more recent information, and the more recent information is that we've now discovered that there are some planets where the star's spinning this way and the planet's orbiting like that. That is totally contrary to the nebular collapse models. It just blows them away. And in some cases, It's in some cases it's more than 90 degrees, so the planet's technically orbiting backwards.
There are planets and even moons in our solar system that have what's called a retrograde orbit, which you would expect if everything is, collapsed nebula, it's because it's spinning. You think everything would be spinning the same way, but there are things that are spinning the opposite direction.
Yep.
Is that correct?
Now all the planets orbit the same way, so that they're good there. But Venus spins exactly backwards. Uranus spins on its side. You wouldn't expect that. Now, some of the real small moons could be captured asteroids, and they could be captured in a retrograde orbit. So I won't fault them there. But then you got moons like Triton, which is a relatively large moon that orbits Neptune exactly backwards from the way that Neptune rotates and orbits, for that matter. So so the existence of retrograde rotations, and in the case of moons, retrograde orbits of a large moon like Triton, very difficult to explain if the solar system collapsed from a nebula. You really wouldn't expect that. And so the secular explanation is, well, it didn't start that way, but something changed it. But even that's hard to do. How do you change the rotation of a planet? Something like Venus.
That's often mentioned. This is mentioned by Alex Williams and John Harnett in their book as well. It's called the sticking problem. I think Saturn I think the nebula hypothesis claims something like planetisms or something like that. That originally, and they did kind of stuck together and formed the planets and stuff. And of course, Saturn has these around that, but when we see them bumping into each other, they either blow up when they bump into each other or bounce off each other, but they don't stick.
Yeah, they don't form moons. That's true. And that is an outstanding problem in secular planetary science. How do you get these particles to stick together? Because at a certain point, they accumulate enough mass that when they bump into another particle, they sort of ricochet off. They don't actually gain any additional mass. So the problem of getting planetesimals to stick together in substantial quantities to be able to be the seeds then for gas to collect around it and so on. So yeah, that is a problem in the secular scenario.
I want to talk real quickly about the evidence from design, but before I do that, I want to ask a question. A lot of old Earth creationists believe that the Big Bang Theory was designed, that they see design in the Big Bang, which is different from how atheists look at the Big Bang. And from what I understand from John Harnett and Alex Williams' book, they said that if the Big Bang had happened, you would expect it to be extremely designed. I guess the idea is, in order to have something that random and chance happening, it would need precision. Would you mind explaining? Well, explain, does the Big Bang require design, or is design just expected because of the naturalistic random way in which it, because some theistic evolutionists will say the same thing about evolution as well. But how would you view that as far as design, the Big Bang, what's claimed by the Big Bang Theory and so forth?
Well, yeah. And keep in mind, the Big Bang was designed to explain how the universe could come about without invoking the supernatural, without invoking God. And again, Lemaitre was not an atheist, but he was a methodological naturalist. So so to say, yes, there's a Big Bang, but God started it, defeats the purpose of the Big Bang. It's designed atheistically, albeit not by an atheist, interestingly. So you can make those kind of arguments. You can point out that with the flatness issue, the fact that the gravitational force is finely balanced with the expansion rate, but that equally well makes sense, and it makes more sense in light of the creationist expectation that the universe is well designed. And so, of course, those things are going to be balanced. We'd expect that. So I would say I would avoid trying to use the Big Bang because it's false. It's contrary to what God's word teaches as an argument for design.
In the biblical age, the universe is going to be the same age as the Earth and human beings, 6,000 years old. And but in the secular model, they see the Big Bang as being 14 billion, the Earth being 4.5 billion, and all life being about 100 million or something like that years old, 100, 200 million.
Depending on the species, yeah.
And so, but there's evidence that the universe is much younger than that.
Oh, yeah. Quite a lot. The rate at which spiral galaxies wrap is one example of that. And I ran some simulations on this. I was sort of curious to see how severe the problem was, but I took I think it was the Whirlpool galaxy. I took it and I used the measured speed of the rotation of the stars to see how long, because galaxies rotate differentially, meaning the inner portions rotate quick, the outer portions rotate slower in terms of their angular velocity. And if you think about what that means, it means that spiral structure would have to get tighter and tighter every year because the inside's twisting more than the outside. So it's getting twisted up tighter and tighter. And so I ran some simulations based on the measured speeds of these stars, which we have data for that. And I found that by 100 million years, the galaxy's totally twisted beyond recognition. You can't
Isn't there
see.
something about the magnetic fields that the magnetic fields seem to be winding up itself? Because winding up the density wave theory doesn't really explain the magnetic fields very good.
Yeah, there's a connection there. So the connection is this: secularists are aware of this problem, and they know that galaxies wrap themselves up and would be not spirals anymore in far less than 1 billion years. And galaxies are supposed to be 10 billion years old, typically. Galaxy like ours, galaxy like the Whirlpool. So the secular explanation is that, yeah, the arms do get all mingled up. They do get all twisted, but new spiral arms form because there's a compression wave that moves through the galaxy that triggers star formation. And so it creates these new arms, and then they get wrapped. But then as they're destroyed by wrapping, new spiral arms form, and so on. Okay, now there's problems with that theory. And one of them is magnetism, because it turns out that, yes, you can have density waves like that. There's no evidence for them, but you could theoretically. But magnetic fields, the magnetic fields of a galaxy are parallel to these spiral arms. Okay, so if you follow the magnetic field, your compass would line up with the spiral arms if you were to hold a compass at that galaxy. And believe it or not, we can detect that spectroscopically. But the problem is if magnetic fields have to move with plasma, and so ionized gas. And so as the spiral arms wrap up, the magnetic fields would have to wrap up too, to the point where they would eventually reconnect, where south and north would snap together and it would disintegrate itself. And so if the density wave hypothesis were true, you would not expect the new spiral arms would have the magnetic fields tracing them, because they should have been smeared up by the old spiral. I'm not explaining that very well, but basically the fact that the magnetic fields line up with the spiral arms tells you that the density wave model cannot be correct.
And there's also an abundance of blue stars as well. You often talk about that. I remember in a debate you did, one of your many debates with Hugh Ross, you mentioned if the universe was old, we would expect to see the universe filled with red stars rather than blue stars, and very few blue stars, if any, should be there. And
there shouldn't be any.
Right. And Hugh Ross's response to that was, no, in an old universe, we'd see blue stars and red stars, which I think he just argued that because that's what we observe, but what we observe is not adding up to what he believes. And but we have, when I sat there and began to look and research, I found what was it, 2 blue stars in the Big Dipper or something like that, that they have blue stars in it. It's really stars.
Yeah, the Orion's belt, for example, there are blue stars in Orion's belt. Now, blue stars are not as common as red stars. That's true, and we'd expect that too, because red stars, like red dwarfs, extremely common, and that's because they're low mass. And there's an orderliness in God's creation to where things that tend to be smaller, there tend to be more of them, and things that are larger, there are fewer. And that works for stars as well. The less mass of the star, there are more small mass stars, low mass stars, than there are high mass stars. And the blue stars are high mass. They have to have that much energy. So, and we do see them. We see more blue stars than red stars because they're easy to see because they're brighter. But there are more red stars. But in an old universe, there should only be red stars. And the reason for that is blue stars can't last very long. Blue stars cannot last. The hottest blue stars can't last more than 1 million years, 1 million, let alone 13 billion. And so the fact that we have blue stars pretty much everywhere is an indication that the universe is not that old. And by the way, secularists do not dispute that blue stars can't last hundreds of millions of years. They know that. They can do the same math I can do. And it's a very simple calculation. We know the amount of material that's there, and we know the rate at which the star is burning it away because we can measure the energy from it. You just divide distance, and you get the amount of time that a star could last, and it's like 1 million years for the hottest, bluest stars. So they don't dispute that. The secular explanation for why we find blue stars is that they have formed recently from a nebula, and that includes areas of space where we find no nebulae, but we find blue stars there. But a lot of times you'll find a nebula and blue stars in it, and secularists will call that a star-forming region because they assume stars are forming there. Now, let me clue you in. No one has seen a star form. No one has seen a star in the process of formation. We thought maybe years ago when we looked at these Proclids and the Orion Nebula that they were stars in the process of formation. We now know that's not right. They're not collapsing. But in any case, when secularists say we see a star forming region, what they really mean is we see a region with lots and lots of blue stars, which cannot be anywhere near hundreds of millions, let alone billions of years old. And so they assume that new stars have formed there.
Right. Or they'll see gases moving and they'll assume that it's about to form or something. Hugh Ross, he has you've debated him a number of times. And I always like watching y'all debate. So it's always cool to watch that. But Hugh Ross has a tendency to make a lot of bold statements that just cannot be backed up factually. And one of the statements he makes is that you can actually observe star formations, which you cannot observe.
Right.
Do you know why he makes that claim that you can observe, that this is observable? You know, that you can observe star formations, or is he just assuming the star form, like you said, in these star forming regions or something?
It has to be the latter. Yeah, it has to be that he's taken the secular view that, well, we all agree that blue stars can't last billions of years. We all agree on that. Even 100 million years, 10 million years. The hottest blue stars, million years maximum, maybe a little less. And so when you find a region that has a lot of these blue stars in it, the secularists have to assume that stars have formed there recently, and so that they're looking at a star formation region. But in terms of actually seeing gas in the process of collapsing in on itself, we've never seen that. We've never seen that. There's no evidence of that. And I would challenge any astronomer, show me any peer-reviewed technical article that shows observations of gas collapsing in on itself. And I'll stop making that claim if they can tell me that. But I haven't had anybody be able to show me that.
I'm not going to deal with every evidence there's a lot of evidence, but I'll probably go and do a different thing on that. But I do want to ask you about comets real quick. Comets can't last as long as the secular timescale. Now, originally, when they first proposed the nebula hypothesis, they thought comets formed in the early parts of the solar system, but then they realized that the comets can't last as long as they think the solar system did. And so they started coming up with, I guess, what you call a rescue device, where they would come up with like the Oort cloud, or assume that the material is coming from what's called the Kuiper belt. Do you want to explain that one on that?
Yeah. So you're exactly right. The original assumption was that, well, comets formed, and they still believe that comets formed when the solar system did, because that's the only way you can get them. But how do you preserve them? Because a typical comet, we can measure the rate. When you see a comet, you see that lovely tail. That's material being blown away from the source of the comet. This comet's an ice and dirt, and when it orbits the sun, they tend to go far out, and they come close to the sun and get whiplashed back out. If there were any comets that were just continually,
I was going to say the tail always faces away from the sun because that's the material that's being blown off.
Right. Sometimes people think it's going that way. No, you don't know which way it's going. You just know that if the tail's that way, the sun's that way, because the material is being blasted away. Now, sometimes it'll curve, because if the dust that's being released, it basically gets launched into its own orbit, and so it'll curve away. The ions point straight. So comets usually have two tails: an ion tail, which is kind of bluish, and then a dust tail, which is kind of yellowish. And the dust tail curves. They're beautiful. They're fun to see. I've seen a lot of comets in my life, and they're a blast to look at. But they can't last more than about 100,000 years maximum. And some of them are much less than that, because there are some comets that presumably were created about 6,000 years ago that no longer exist. I've seen comets using the SOHO spacecraft that do not exist anymore. They went behind the sun and they were completely destroyed in one visible pass. So we know they don't last hundreds of thousands of years. And yet we still have comets in a solar system that the secularists believe to be 4.5 billion years old. How do you do that? So the current rescuing device is that the early comets, many of them got kicked out into a much larger orbit by Jupiter. So Jupiter kicks them out in this deep space, and then somehow their orbits get kind of circularized and they form a cloud out there, which is called the Oort cloud, named after the inventor Jan Oort, who came up with the idea. And so the idea is, well, now they're far away from the sun. They're not comets, they're just ice particles. There's no tail or anything. They're too far away to be heated. And so they can remain there for billions of years. And then every now and then one of them gets kicked into the inner solar system to become a brand new comet. So as old comets disintegrate, new ones get kicked in from the Oort cloud to replace them. And that's pretty clever. There's no evidence for it. These icy bodies are out beyond the distance of our technology to detect. I don't think we will detect them. They might find objects orbiting at that distance, but will you find sufficient quantity to explain? You need a lot of these things. You need a lot of these Oort cloud objects to explain the quantity of comets that we have around the sun now, especially long-term comets. And it's even more complicated. Go ahead.
The objects in the Kuiper belt, it's different composition, different mass, from what I understand. How do they account for that? Because the material is different. It's not. I think, if I'm not mistaken, they're much bigger than the comets that we actually observe.
So that's yeah, so the Kuiper belt's a little different because there's two types of comets. There's long period comets, which have an orbit by definition greater than 200 years. It's greater than 200 years, it's a long period comet. If it's less than or equal to 200 years, it's a short period comet. And the interesting thing is the long period comets have a almost random trajectory, not perfectly random, but they, like if this is the plane of the solar system, a long period comet might come in from like that, go back out like that. It might have an orbit like that, or like that, or like that. I mean, they can be in any orientation. Whereas the short period comets, they tend to be close to the plane of the solar system, and they tend to orbit in the same direction as the planets. Usually, there are exceptions. Halley's Comet is an exception. It's a 76, 77-year period, but it orbits backwards and not quite in the plane of the planets, but it's pretty close. And so the idea is, well, how do we explain these two different types of comets? And the secularists have said, well, there's the Oort cloud that explains, and it's spherical, so that's why it explains the long period comets, because they can come in from any direction from this Oort cloud. And then there's a Kuiper belt, which exists out beyond Neptune, and that's where all, and it's kind of a disk. It's a disk, and so that's where the short period comets come from. And we have found objects out at the distance of what the Kuiper belt was expected to be, but there is some question as to their composition and their color. Sometimes we can't get the composition, but we can get a color for it, and that gives us a feeling for what they might be made of. And some of them are tilted more than others, and there's actually a correlation. I forget what it is, but some of them are redder, and they tend to be higher inclined or lower inclined, I forget. But it's not what you'd expect if these were just comets. And they tend to be, as you pointed out, they're much larger than comets. Largest comet we've seen, Hale-Bopp, had a nucleus of, I think it was like 40 miles across, which is massive. These things are much bigger. They might be 400 miles across. Pluto basically is an enormous one of these Kuiper belt objects. So that really calls into question whether they could be comet progenitors given their massive size.
In one of your debates with Hugh Ross, this is the one that was moderated by Frank Turek, I remember, that you had with them. And Hugh Ross brought up something in the discussion. He claimed that we know Kuiper belts exist, or not Kuiper belts, but Oort clouds exist because we observe them in other solar systems. And I started looking that up, and I found out that even secular astronomers would say, no, we have never observed an Oort cloud in another solar system. What they do is they assume that since they assume that the Oort cloud formed in this solar system, it formed in other solar systems, and so that's what they end up assuming. And so they've actually never observed, and they admit that they never observed an Oort cloud. It's like it's supposed to be like on the other side of the sun, and we're always not in observation to it, something like that. But they admit that. But the assumption is because they assume it formed here, they assume it formed there. But Hugh Ross kind of made the statement that we observed Oort clouds in other solar systems, but that's not even accurate, is it?
It's not accurate. It's not accurate. We do observe that some stars have material around them, dust, for example, and we can measure that. But the idea that they have trillions of potential comet nuclei orbiting around them, that's purely theoretical. We have no observations to support that. And the fact that we can't even see an Oort cloud in our own solar system, which is relatively close, really should cast doubt on someone who makes the claim that, well, we can see them in other solar systems that are much further away. So no, we don't have, and by design, a good rescuing device can't be refuted. And so and the nice thing about the Oort cloud is it's beyond our technology to either confirm or refute. And so the secularists can continue to believe in it, but if they claim that we've seen one, they're mistaken. And I think Ross is very much mistaken about that. We do detect evidence. We do detect evidence of dust around other stars. There's no doubt about that. But the idea that there are trillions of comet nuclei, we just don't see that.
Hugh Ross has a tendency to make these kinds of bold statements, and then when you look them up, you find out even secular astronomers don't say that exactly. Yeah. I wish we could have talked a little bit briefly about your model on distant starlight. I kind of wanted to briefly touch on it, but we really don't have time now. But I hope that you will be willing to do, because I was wanting to do a presentation on your model for ASC, anisotropic sequencing convention and I also a general discussion over distant starlight and the different models that come up with and that sort of thing, and as a separate video.
Yeah, we can do that.
I don't know what your schedule's like, but I'm gonna email your assistant and see if something can be arranged in the books. But I was hoping to put that on this series. But I would love to talk about your particular model. We just don't have time today. Yeah. And but this has been great. I always learn something new whenever I have a discussion with you. I know we haven't had one in a while because I had school and I finished those classes, and then but I thought it would be great to have you on here again and to have this discussion. And last time we talked about presuppositional apologetics and transcendental argument, and I think that there's some when you talk about rescuing devices, there's some hint at that so you can always come up with some kind of a rescuing device to save your worldview. The real issue is your starting assumption here. And the starting assumption, and we didn't talk much about this, but the starting assumption of the Big Bang is naturalism and uniformitarianism, and because you have to assume that ultimately. Yep,
that's exactly right.
Awesome. All right. Well, I guess this ends this discussion, and I hope to see you again, hopefully soon, if we can set up something for the your ASC model to have a discussion on distant starlight.
Okay, sounds good.
Thank you, and thank you for joining me, and I will see you later, Dr. Lisle.
All right, thanks. God bless.
You too.
Well, that will be it for today's video. Thank you for joining me on here. Don't forget to like the video, subscribe to my channel, and hit that notification bell. Please drop me a comment below. Let me know what you think of the video. I've got more videos coming soon. I've got a presentation that I want to do on the traditional translation of Genesis 1:1 versus the dependent clause translation of Genesis 1:1, and that's hopefully coming soon. I'm trying to enter. I haven't heard back from him since I sent Dr. Marcus Ross the last email, so I'm hoping to have him on my channel eventually if he gets back a hold of me, and discuss whether he can be able to do a debate review with me with the debate he had with Michael Jones. Hopefully that will happen. I don't know if that will or not, but we'll see. And so, but I got lots of other videos planned out for this series, the Genesis series. And so please join me on my next video. And it was a pleasure again to have Dr. Jason Lau on again. I'm hoping to have him on soon because I'm fixing to get a hold of his assistant and see if we can set something up for another interview on the Dr. Jason Lau's ASC model, as well as a general discussion of the so-called distant starlight problem, um, and have a discussion over the different models that people come up with and so forth. And hopefully that will happen at some point in the near future. And in the meantime, remember, always stay in the know. And this is Brian Bowen from Apologetics 101 signing off.